Good evening, all of you. Welcome you guys. Welcome you all of you. I hope we are live. First of all of you confirm this audio and video. Is it clear to all of you? Tell me first of all. So could you please confirm whether this audio video is clear? Right? Welcome you guys. Welcome you all. Welcome to the Gate Conquer. So welcome to the Unacademy, India's largest online education platform guiding a number of students to achieve the dreams of many students. To achieve the dreams of many students. Welcome you guys. Welcome you all of you. Yes. So we have a small announcement from Unacademy, and we have a small announcement from Unacademy. So the Unacademy is going to conduct a grand scholarship test on the 26th June at 11 a.m. So with this, there is chance to get a 90% of the scholarships for the Unacademy subscription. So all of you try to utilize these opportunities. And you can enroll for this course by using a code of BV Reddy. You can enroll for it by using a code of BV Reddy. Right. And coming to these special classes. So the Unacademy special classes are very interactive with the students, live interactions. Polls will be during the classes and which is not possible in the YouTube classes. And raise the hand, never miss a class, lecture, notes, and the anytime, anywhere you can access the classes. And you can take the Unacademy subscription with a no cost EMI without any additional in payment. You can avail the Unacademy subscription. So no need to pay any additional extra charges also. So within 2 hours, you will get the approval and minimum paperwork and flexible tenures according to your comfortable. You can choose your tenure. So 6 months, 18 months, 12 months, like that you can choose the options. And there is a daily scholarship test, and the student who are not able to pay the full fee, and you can utilize this opportunity. So by using this, you get a chance to get 50% of the scholarship. Right. And the Unacademy community features. With the Unacademy community, you will get the about the free classes and plus classes, batch schedules and all, notes, DPP, etc. आपको मिलने वाला. Next, these are the new batches you can see now here. And so you can see the top educators of India available here. June 15th onwards, new batches has been started. And so as you might know, from the June 29th onwards, I'm going to start the digital. And the July in plus course. These are the plus courses. July 13th onwards, I'm starting the signals and systems. So you can enroll for these courses immediately. So you can take the subscription by using code of BVRD and to avail the great discounts and to get the personalized guidance from me. So you will get the complete short notes, full notes, handwritten notes. Everything is available, and DPPs and DPP solutions also will be provided. Next, and you can see practice all the PYQs with the Unacademy PYQ series. And these are the GATE 2022 top rankers from Unacademy. And these are the ESE 2021 top rankers. And with this Unacademy, you can get plus subscription. You will get top educators and doubts clearing session, study notes, test series. And with the iconics, you will get additional benefits of physical notes आपको मिलने वाला, and you will get one-to-one live mentorship program and strategy and study programs and live interaction with the educators. And you can take the subscription by using a code of what? BV Reddy to get the great discount and personalized guidance from me. चलिए, let's start our discussions, all of you. Yes. How many problems we have completed the last class? Tell me. How many problems we have finished the last class? Okay. Yes, I think 37 completed, right? Next, take the next problem, all of you. The next problem, take down here. Given initial charge in Q naught. Q naught is given as a 400 microcoulombs in steady state. Find the charge in 1 microfarad capacitor. Take down this problem, all of you. Take down this problem, all of you, and try to solve this problem. They given the in Q naught initial charge. They given the charge of this capacitor has been given, and the capacitance value given as a 5 microcoulombs. So from this, as we know here, Q is equal to C into V, right? From this, can I get this my voltage across the C naught capacitor? So what we can say, this voltage V naught, which will be given as what we can say here, Q naught by C naught. Can you tell me how much is voltage here? Q naught, which is equal to 400 micro, and C naught, which is equal to 5 micro. So then how much is voltage, you tell me here? 100 volts. That means this voltage across this capacitor, which is equal to 100 volts, right? If this voltage is 100, and they mention that the circuit is in steady state. In steady state, what happens, you tell me? The capacitor will behave like what you tell me now? Open circuit. In steady state, capacitor will behave like an open circuit. Then can you tell me how much is flow of current in this circuit? There is no flow of current. If there is no flow of current, now this current through this resistor, which is equal to 0, then voltage across this resistor, which is equal to 0. That means the voltage across this parallel combination of these capacitors, which I can call this as 100 volts only. The voltage across this parallel combination of capacitor is 100 volts. That means the voltage across this capacitor is also 100. They are asking to find the charge in this capacitor. So as we know, voltage we know, capacitance we know. From this, what we can say now here, Q is equal to, okay, fine, sorry. So I didn't observe this thing here. Fine, I will write in the left side, I will write, don't worry. Okay, so the Q, which is given as a C into V. So how much the charge in the capacitor here? 1 micro into voltage is how much here? 100. So that is, which is nothing but 100 microcoulombs na? 100 microcoulombs. Right, all of you? Till the next problem. Take down here. The switch K is opened at t equal to 0. Find IL of 0 plus. Find IL of 0 plus. The switch is opened at t equal to 0. Now tell me now here. They ask him to find the IL of 0 plus. IL of 0 plus, as we know, inductor does not allow sudden changes of current. So that is IL of 0 plus, which is also equal to IL of 0 minus only. Na? That means we just want to find the initial value, IL of 0 minus. So consider network at t equal to 0 minus. At t is equal to 0 minus, what happened now? T is equal to 0, switch is open. T is equal to 0 minus, what happened to switch now here? The switch is closed only now. Switch is closed. If the switch is closed, then what happens now here? The network which is in steady state, the network is in steady state. In steady state, what happens, you tell me? In steady state, how this inductor, you tell me? Inductor will behave like a short circuit. So can you draw this network now, tell me? Now switch is closed and inductor is shorted like this. Now 12 volts and here is a 4 and this is 2 amps and this is 10 and here this current we need now. This is IL of 0 minus, right? Now you can see now here. So since it is shorted now here there is no flow of current, so this 10 ohm resistor is a dead element. Now you can see now here this current whatever given by this thing, this current will flow here now. So this is shorted path. So what we can say now, tell me how much this current will flow here. Now so if I convert it to source transformation, we can do this thing here if you want. What you want to do here, directly we can write. So here if we apply the source transformations, how much this current value, tell me, by applying source transformation? And so this current, and which is equal to 3 amps and the 4 ohm resistor is in parallel and this is 2 amps and here we have this is short path. This current which is IL of 0 minus. So complete current will goes in the via short path only now. So that means IL of 0 minus which is equal to how much, you tell me now? 5 amps. So I can say IL of 0 plus which is also equal to 5 amps only. IL of 0 plus which is also equal to 5 amps only. Right? Option A. Done everybody? Now chalo next problem. Take this problem. What is IL2 of infinity? IL2 of infinity. This type of problems we have seen for in case of a capacitors we have seen. Did you remember? This type of problem we have seen for capacitors. Now this is for the inductor. Now try this problem all of you. Now first of all they given initial values now here. So how this initial value of the inductor L1 is given, right? Now for t greater than 0, can I develop the equivalent circuit of this inductor? This is for t greater than 0. How the equivalent circuit of inductor? Inductor equivalent circuit. So inductor will contain a parallel initial current. So they didn't mention the inductor L1 in initial current is given. How much the L1 initial current is a? Inductor will have a parallel initial current, right? And this is L2. L2 does not have any initial values. Now this R is given as a 10 ohms. And this L2 which is given as a 2H. L1 is given as 1H and initial current is given as a 2 amps. This is the circuit for t greater than 0, right? Now, Let us convert the network into S domain Laplace transform. So then it will becomes S na here 1 into S, and this value 2 by S, and this value will becomes 2S ohms na here, and this is resistance only, right? Now if I call this voltage is something V, if I call, and now since we have, so I can write the nodal equation at this V node. Tell me now here this current, what we can say now here, V by S plus this current is a leaving current only now here, which is equal to 2 by S plus V by 2S plus V by 10, which is equal to 0. Check it all of you this equation. Now let's simplify for V. Tell me here, V we have taken common, then which will becomes 1 by S plus, so here this is 1 by 2S, 1 by 2S, and plus 2 by S plus V. V is also there now here. I can use here this thing, which is equal to 1 by 10, and which I can say this as minus 2 by S. And take LCM and simplify for V. Tell me what we'll get now here. So I can say this is 10S is a LCM, so which is given as a 5. Okay, no 10 here. This is 10 and this is 5 and this is S, which is equal to minus 2 by S. So how much this V value, tell me? S will get cancelled, which is equal to minus 20 by S plus 15. Check it now here, all of you. This is my voltage. This is my voltage. Now we need, what we need here, tell me? We need the current. So here they ask you to find the finite. So the current through this element we need at infinite. At infinite time we need the current. So this is the voltage. From this I can get this current now, first of all IL2. That is IL2 of S, which is given as V of S by the inductance L2, which is equal to 2S now ohms. So from this, what I will get now here, IL2 of S, which is given as V of S, which is equal to, this is minus 20 by, so this is 2S into S plus 15. S plus 15. This is the current through the second coil. Now I know the Laplace domain, but he is asking to find IL2 of infinity. So what I can do here, I can go for the funnel value theorem. I know IL2 of S we have, which is equal to minus 20 by 2S into S plus 15. Let us use a final value theorem. Final value theorem. By using final value theorem, so this is x of infinity, which is given as limit. So here s tends to 0, s into x of s. So let us do the final value theorem here. So that means what we can say here is IL2 of infinity, which is given as limit s tends to 0, s into minus 20 by s plus 15. S will get cancelled. So what we have is a minus 20 by 2 into s plus 15. When I place s is equal to 0, then how much the value you can get, you tell me? which is equal to minus 20 by 30, right? So which is given as what we can say here, minus 2 by 3. Everybody, minus 2 by 3. So that means here this value to be a minus 2 by 3 now. And hello, next problem. What is a VL of 0 plus when the switch K is closed at T is equal to 0? When the switch is closed at T is equal to 0, VL of 0 plus. The switch is closed at T equal to 0 here. Now try this thing here. So first of all, they ask him to find the VL of 0 plus. Means what is this VL of 0 plus? Is a transient value or steady state value? Tell me. Is this 0 plus values mean transient values or steady state value? This is a transient values. 0 plus values are called as what now? Immediately after switching action means those are called as a transient value. Transient values will depends upon the past behavior. Transient values will depends upon the भूतकाल में depend होने वाला, isn't it? So that's why whenever they ask him to find the transient values, first of all, we need to analyze a network previous state. That means before the switching action, we need to analyze it, right? The switch is closed at t is equal to 0. Before that, what now here? That is t is equal to 0 minus. T is equal to 0 minus. What happens now? Switch is opened. If the switch is opened, then the supply connection is there. Supply connection is there only for the inductor. Supply connection is there only to inductor. There is no supply connection for the capacitors, right? We have supply connection is there only to the inductor. There is no here. So inductor only reaches to steady state. Only the inductor only reaches to steady state. Capacitor knows energized, isn't it? Only the inductor reaches to steady state. Inductor is in steady state, fully charged, isn't it? If the inductor is in steady state, so inductor will behave like what you tell me now here. So the inductor will behave like a short circuit. Now tell me now how much these values now tell me. I can say this current, if I call this current as a IL of 0 minus, we can say. So this is IL of 0 minus at t is equal to 0 minus values. Let us call this current as IL of t. And this voltage, which I am calling it as VC of t, which is equal to 2 amps. And VC of 0 minus, which is equal to 0 volts. Right. So from this, what we can say? Yes. So I can also write it is IL of 0 plus. This is also equal to VC of 0 plus. Okay. These are the VC of 0 plus. Now let's talk about at t equal to 0 plus. Now let us talk that at t is equal to 0 plus. Now t is equal to 0 plus. What happens? You tell me. So that is immediately switching action, which is called as a transient state. Immediately switching action, which is called as a transient state. Immediately switching action, which is called as a transient state. In transient state, what happens? You tell me now, switch has been closed. Inductor will behave like what you tell me now, open circuit. Now capacitor will behave like a short circuit. Now tell me now here, if I draw the circuit now at t is equal to 0 plus. How the scenario now, tell me? At t equal to 0 plus. Inductor having the initial current and capacitor which is shorted. Now we need this voltage we required, isn't it? This voltage and this current which is equal to 2 amps. This voltage which is called as a VL of 0 plus and which is equal to 1, and this current which is equal to 2 amps. Now since it is shorted path, can you tell me here this current which is equal to how much, you tell me here? This current which is equal to 2 amps. Now so this voltage which is equal to 2 volts. 2 volts. Now since this is a shorted path, this voltage is 0. That means the voltage across this branch is also 0. Isn't it? If we write the KVL in this loop, what happens, you tell me now here? Which is equal to minus VL of 0 plus minus 2, which is equal to 0. So that means what we can say here? VL of 0 plus, which is equal to minus 2 volts. All of you. VL of 0 plus, which is equal to minus 2 volts. Done. Next, take the next problem. An impulse current 2 delta t with time is in seconds is made to flow through an initially relaxed capacitor. The capacitor voltage at t is equal to 0 plus is initially relaxed capacitor. That means what you tell me now here? What is the initial voltage across the capacitor? Vc of 0 minus, which is equal to 0 volts. Okay, they asked to find what you tell me now here. Vc of 0 plus value they asked to find. Vc of 0 plus. What is the Vc of 0 plus is a? So capacitor does not allow sudden changes of voltage, isn't it? So that means Vc of 0 plus, and can I say that which is also equal to Vc of 0 minus? Yes sir, now tell me. Vc of 0 plus, can I say that which is also equal to Vc of 0 minus? Ana boliye. Right. Vc of 0 plus equal to Vc of 0 minus. This is true, but under certain conditions. Under certain conditions. Right. So this is true provided. So this is a practical situation. Practical sources only this will be happens. Practical sources. Only it can happens. Right. But the thing here they apply the current source which is equal to 2 into del of t. Is the del of t is a practical source? Is it physically realizable signal? Will it be, is it possible? So it is not possible. So tell me now here, remember here. So that's why Vc of 0 plus in case of impulse signal Vc of 0 plus, which is not equal to Vc of 0 minus. This is for the ideal situations. Ideal case, this is not happens. Remember, for the ideal sources, this condition not satisfied. Inductor does not allow sudden changes of current for the practical sources, and capacitor does not allow sudden changes of voltage for practical cases only. For the ideal cases, it can happen. I hope you have remembered these derivations. While doing derivations, we have taken the 0 minus to 0 plus, we have taken 0 minus to 0 plus, we have only signal which can exist is an impulse signal, isn't it? Right. Now the signal what they given the source, which is given as the impulse current they applied, right? Capacitor is equal to 2 into del of t, and this is 3 farads. Yes. And what we can do, if you want, you can do the time domain, you will go for the frequency domain also. That means S domain also we can do. So we just want to find the voltage now here. This voltage we need to find now here. This voltage I need to find. So this is, and this is the, my VC of t. What we can say VC of t, basically VC of t, which is given as 1 by C from where to where, minus infinite to present time of what we can say now here, IC of t into dt. So that means what we can say now here, VC of t, which is given as, which is equal to 1 by 3, and you see the initially relaxed though in no initial value, right? So which is equal to what we can say now here, that is we need at t is equal to 0 plus, that is we can say this is 0 minus to 0 plus IC of t, which is given as 2 into del of t, 2 into del of t into dt. So how much this value we can say here, 2 by 3 into, we have 0 minus to 0 plus, and this is integration of del of t into dt. So tell me how much this value. So between 0 minus to 0 plus, here t equal to 0 plus. So from this what we can say, VC of 0 plus within the interval, the area bounded by impulse signal, which is equal to 2 by 3 now. Done. So I hope all of you know here. So from this 0 minus to 0 plus, this is the area bounded by the impulse signal, which is equal to 1. Done. Next one. So try this problem. The circuit or the figure is initially relaxed. That means the switch is closed at t is equal to 0, right? So at t is equal to 0 plus, they given the which will be the satisfied. Now initially at t equal to 0 minus, t equal to 0 minus, you can see now here there is no supply connections, right? There is no supply connection, so then VC of 0 minus, which is equal to 0 volts. Next, IL of 0 minus, which is also equal to 0. No sources. Now at t equal to 0 plus, at t equal to 0 plus, now you tell me now what happens? Which is closed, which is nothing but transient state now, which is nothing but transient state. In transient state, so the inductor will behave like what you tell me now here, open circuit, and capacitor will behave like a short circuit. Now draw the circuit to tell me now at t is equal to 0 plus, and how the capacitor which is short circuited and inductor is open circuited, and here we have a resistance which is equal to 1. So this voltage which is a V, and this current is I given, and here this is 100 volts, right? So that means by observation what we can say, V which is equal to 100 volts and I which is equal to 100 amps, isn't it? So consa option satisfy, only option C will satisfy. Now this type of questions may be possible to get MSQ type of questions, isn't it? They will give this as, might be they will give the current is also, if they given is 100 is given. So MSQ type of questions may be possible here. Then next, the time constant of the circuit. Time constant of the circuit is which we can say this as R equivalent into C equivalent, right? Time constant generally we used to do always after the switching actions. At t is greater than 0, what happened to switch now here? Switch is closed. Switch is closed. Right, when the switch is closed now here, so draw the connection now here. Voltage source को deactivate करो. Now here is a capacitance. With respect to capacitance, we need to find the R equivalent. Here is a R1 and this is R2. So with respect to capacitor, we need to find this is A and B. How this R1, R2 are in parallel. So this is R equivalent, which is given as R1, R2 by R1 plus R2. So that means tau, which is given as what we can say here, C into R1, R2 upon R1 plus R2 and B. Next, if I1 of t is 5 amps at t is equal to 0, find I1 of t for all t, if Is is given as a 10 e power minus 2. Means what they given now, I1 of t at t is equal to 0. So that means they given this is I1 of 0. I1 of 0, that is the initial current through inductor I1, which is given as a 5 amps. And they given Is is given Is of t, which is given as a 10 into e power minus 2t. Right. Now you tell me what we can do here. So कोई ख्याल है तो बोलिए, what we can do. Now I know this Is, so I want to find the voltage here. I want to find this voltage. For this I need to find the equivalent inductance is required. Now tell me. Yeah, we can do Laplace also. It is, even the Laplace it will become lengthy, right? So can I find the equivalent inductance? You tell me, all of you. How these two inductances are here? Parallel. This is 1. I can say this is 0.5. This is 0.5 H now. These two are parallel. This is not an ideal situation now. The supplies are, what you tell me, supplies is a practical sources only now. It's a practical sources only. So this is no need to worry about this thing, right? If it is ideal cases, then we can see. Now this inductance value. So how these two are parallel? Can you get the equivalent now here? That is 1 parallel to 1 by 2. So tell me how much the equivalent inductance here is equal to. So this is 1 by 3. Isn't it? 1 by 3 H. If I know this equivalent inductance Is, now this current is Is only now. Can I find this voltage V? So the voltage V, which is given as what we can say L equivalent into what we can say here DIS by dt. DIS by dt. So that means V, which is given as, which is equal to 1 by 3 derivative of this current. What will get, you tell me here, which is equal to minus 20 into e power minus 2t. So that means if I say this is my Vs supply voltage, I can say. So this Vs, which is given as minus 20 by 3 into e power minus 2t. Check it all of you. Minus 20 by 3 into e power minus 2t. We got this voltage, means this Vs and this voltage also same only now. This voltage also Vs only. I know voltage. Can we get this current now here? So what we can say now, this is I1 of t. Of course, they given initial value of inductance value given. So what we can say, this is, which is equal to I1 of 0 plus 1 by L into integral of what we can say here 0 to t VL of t, that is Vs I can say. Here VL means what? Vs na? Supply voltage. So this is Vs of t. So just simplification only na. So IL of 0, which is given as a 5 plus inductance, which is equal to 1 by 2, means will come 2 in the numerator. So this is 0 to t into minus 20 by 3 into e power minus 2t. Okay, so that's why what we can say now here, IL of t, which is given as 5 minus, this is 40 by 3, 40 by 3 into e power minus 2t by minus 2, limits 0 to t. So from this, what we can say here, I1 of t, which is given as, so this is 5 plus 20 by 3 na, isn't it? 20 by 3, yes, into e power minus 2t when we subtract the lower limit, and which is 1. Yes. So simplify this thing here. What we'll get here? 5 plus 20 by 3 into e power minus 2t minus 20 by 3. Check it all of you. A simplification. Can you tell me the final answer? How much you will get? You tell me here. I1 of t is equal to minus 5 by 3, isn't it? Plus 20 by 3 into e power minus 2t. So option D. Right? Of course, we can do the Laplace also. I think so. Compared to the Laplace, this way is simple. I think so. Isn't it? Laplace. So try to avoid the Laplace. Why? Because Laplace, if we apply, again we need to do the partial fractions. We need to do it whenever we are doing the Laplace. That's why we'll try to avoid the Laplace. But some cases there is no alternative. We need to go for Laplace only. Hello, next problem. The switch in the circuit of the figure has been closed for a long time. It is opened at t equal to 0. Now the options they given like this. The switch in the figure circuit has been closed for a long time. The switch is opened at t equal to 0. switch is open at t equal to 0. That means now here at t equal to 0 minus, can you tell me the situation of this network? T equal to 0 minus, switch is closed. When the switch is closed, what happens now here? This complete current will flow the short path only. Isn't it? Complete current will flow the short path only. So then what now here? Voltage through the capacitor, which is equal to what you tell me now? 0 volts. Now when the switch is opened, that is at t equal to 0 plus, at t equal to 0 plus, when the switch has been opened, then situation what happens to tell me? When the switch is opened, then only there is a flow of current through the capacitor. So capacitor, it is a transient state now, tell me. Transient state, so capacitor will behave like a short circuit. So this is 1 amp here, this is 1, and this current, which we can say this is I of 0 plus, and this voltage is a V of 0 plus. How much this I of 0 plus here? Which is equal to 1 amp, and VC of V of 0 plus, which is equal to 0 volts. So option C. Next. And take the next problem. The switch is moved from position A to position B at t equal to 0. The current through the inductor satisfy the following conditions. Then the value of R is. Good problem. Right. So here they given this current is given. So at t is equal to 0 means t is equal to 0 plus current is given. Right. Now I can say the t is equal to 0 plus is equal to t is equal to 0 minus only. So from this what we can say at t equal to 0 minus. That means at t equal to 0 minus. So see the scenario where the switch is now, tell me. Now switch is at position A, right? Switch is at position A. So this is now switch is at position A, inductor will reaches to sufficient energy now. So it will be in steady state. It will be a steady state. Then it will behave like a short circuit. So this supply is given as a E1, and here which is equal to 3. They given this current, you see the direction they given. So this current is given. This current which is equal to what you tell me now here. This is IL of 0. Sorry. This current is given. So basically, if you see carefully now here, this is the positive supply in a positive terminal. So basically the current will flow like this. This current basically, which we used to call it as IL of 0 minus. But they given this current, they given notation of I of 0. Right. So this must be same now here, opposite directions. So can you tell me how much is I of 0 now here, opposite direction now, which is given as minus E1 by 3. They given this value which is given as minus 8 is given. So from this what we can say, this E1 which is equal to 24 volts. ये पहला condition है. This is one important thing. We got the E1 equal to plus 24 volts we got. Next, what else we have to find out? Tell me. Now I will do this thing also. At t tends to infinity. Now tell me now, when t tends to infinity, where is the switch? You tell me. At t tends to infinity, switch is at position B now here. Again we have source is there. So inductor will reach us to steady state again. So tell me now, draw the circuit now at t tends to infinity here. Now at t tends to infinity, inductor is shorted, and here the resistance value unknown parameter. Right now this is my E2 and this is R. Now again, so this current, which we used to call it as a IL of infinity, but they given this current only given I of infinity, right? So this means this I of infinity, which is again opposite direction, now tell me, which is equal to, I can say, minus E2 by R, I should write. This value which is given as minus 4 now. So that means I can say this is E2, which is equal to 4R. Everybody, this is one condition we got. E2 equal to 4R. Now let's see, now let us find out the scenario at t equal to 0 plus. At t equal to 0 plus, which is a transient state. Now tell me, in transient state, the inductor will behave like a, yes, it is an open circuit with the initial values. Now let's redraw the circuit now here. At t is equal to 0 plus, where the switch is now, switch is at position B. So this E1 does not affect. Remove that E1. So what we can say now here, we have a resistance combinations, and here we have inductor. Inductor is a open circuited but with a initial current. Now can you tell me the current direction here, and what is the direction of current in this case? Inductor current. This inductor current actually here, which is in from which direction, you tell me? Is E2. This is R and this is my E2. Now this current direction, this is actual direction is left side, you tell me. See here, what is the direction of current here? E2 directions. This is the initial current. Actual direction will flows what direction, you tell me? Right side or left side, you tell me? This is the direction of current. Left side, now tell me initial value of current. So here this is opposite, minus 8. Isn't it? Tell me here. Left side now. So this is minus 8. Mean this direction we can say plus 8. Isn't it? That's why. Which is equal to plus 8 now. Tell me all of you. Now according to given this thing here, we can take this as a positive, this as a negative. This is my VL of 0 plus. Can you find this thing here? This why VL of 0 plus now here, according to this I direction we need to follow. According to I we need to follow here. Now can you write the KVL now here? So this current which is equal to 8 amps. So I can say this voltage which is equal to 8R. Now write the KVL in this loop is equal to minus E2 minus VL of 0 plus 8R, which is equal to 0 now here. So this is basically, this is VL of t, which is given as L into DIL of t by dt, DIL of t by dt. But here they given VL of t, which we can say this is L into di by dt. They given na, since they given this is I, converting to in this form. All of you tell me. Here they given this is current I given. So this is which direction is given? This direction is given na. According to that, we have taken the polarities here. Inductor polarities I have taken. Okay. Now you tell me now here. Now this value, so means what we can say now here, DIL of, so no IL, DI of, yes, DI of 0 plus by dt, which is nothing but that is VL of 0 plus by L na here. They given this value, how much this value given as a 3 given na? So they given this value as a 3. So 3 is equal to, we can say VL of 0 plus by L. From this I can get VL of 0 plus. I'll get this thing as a 3 times L. Inductance value we know. Inductance we know 2 na. So which is equal to 6. Tell me all of you. So this means minus E2 is equal to minus 6, which is equal to 8R. Isn't it? So from this, what we can say now here, this is 8R, 8R, that is minus E2, which is equal to 6. This is another equation. Now if you see previously we have E2 is equal to 4R, we have relations. Can I use this relation here? Then what happens now here, E2, we know this is E2 which is given as a 4R from the given equations. Now we can say here, let us call this is equation 1 and this is the equation 2. Now I will solve the two equations 1 and 2. And by solving the two equations of 1 and 2, so what we can say here, that is 8R minus 4R which is equal to 6. That means 4R which is equal to 6. That R is equal to what you tell me now here, 6 by 4 which is equal to 3 by 2. So finally the resistance which is equal to 1.5 ohms. बोलिए बहुत बढ़िया प्रॉब्लम. Yeah, the students will get chance to get confused at this location while taking this inductance polarities. They chance to commit a mistake here. So here this is one crucial point. He tried, so the बहुत confusion होने वाला इधर. It's a one good point. Right, all of you? Next. Next problem. Here's a small correction here. Find the time. The current through the capacitor will decrease exponentially with a time constant of. That means we need to find the time constant for what you tell me. At t is equal to 0, switch is closed. No, switch has to open. If the switch is closed now, so this capacitor voltage cannot decrease, right? It will increase. Sources are there now. It will increase. So it is now here switch is open. Correct this thing here. switch is opened at t is equal to 0, then they ask him to find the current, so the capacitor will decreases at. So why? Because now here Vc, you can see now Vc of 0 minus initial value at t is equal to 0, switch is opened before it is closed only now, before it is closed. So then this value which is equal to 10 volts, and Vc of infinity which is equal to 0. So what will be the tau? You tell me now here. Capacitor will discharge in this path which is equal to 2 into 1. So then what we can say now, Vc of t, Vc of t which is given as 10 into e power minus t by 2. So the how this capacitor voltage decreasing or increasing? Capacitor voltage decreasing or increasing? So this is the way capacitor voltage decreasing, right? Now if we have taken in this manner, instead of that, if we consider like this, then what happens to capacitor value? Tell me. In these cases, if you have considered like that, then in that situation, what happens? You tell me. Yes. So then Vc of 0 minus, which will be a 0 hoga na, at t is equal to 0, switch has been closed, means 0. Then Vc of infinity, which will becomes 10 volts, right? Next, what will be the tau? You tell me now here. So switch is closed here, then it will becomes what? Not tau is equal to 1. 1 into 1. So then in that case, what happens to the Vc of t? Tell me now here, final value. So that is 10 minus 10 into e power minus t. So it will becomes what now here? 10 into 1 minus e power minus t. Isn't it? So in this case, this value's capacitor voltages decreases. Isn't it? Tell me. This value exponentially decreases. If you draw this plot, tell me now how this variation now here at t equal to 0, this value which is equal to 10. Now after that it will slowly exponentially decays like this. And whereas this thing, if you draw this plot, how this plot you tell me now here? You can see. How this plot you tell me now here? This thing. This is 10 into e power minus t by 2. This is decreasing. And this is Vc of t. How it is plot is now here at t equal to 0, this value which is equal to 0 now, isn't it? At t is equal to 0, substitute now here this value 0 and slowly will be rises like this. Now this is a steady state will reaches to here. So this in this case Vc of t, this is the plot of Vc of t which is equal to 10 into 1 minus e power minus t. Okay. So in this case, if it is decreases means they have to change it now here. Switch has to open. Okay. That's why you can do the corrections like this. This is the thing here at t is equal to 0. Now with what time constant now? With a time constant t 2 seconds. Okay. Fine all of you. Right. Yeah, that's for the today's session and we'll meet in the next class. All of you do like the session. So now here, of course, we have started initially. We have started with the one step. Now we have almost reaches to 50. We are near to the 50, right? So here this small single step only will have a lot of impact and all. Slowly, steadily start this solving the problems. Okay, as I told you now, in this session, we are going to discuss like this. Nearly 350 problems are there on the transient topic. We are going to discuss all the 350 questions we are going to see. Fine. Okay. Okay, then see you. Bye bye. Good night.